All right, this is problem 7.2.31, and we're asked to find the domain of the following function here. So we have f of x equal to -7 over the absolute value of 7x plus 8. And so anytime we're finding the domain, what we're doing is we're starting with the set of real numbers, and then we're making exclusions for any values that give us something undefined in the function. So if you look at this function, in the denominator we have a variable, and if we have a variable in a denominator, it means that there's going to be a point where that will zero out. And we can't have 0 in a denominator because 0 in a denominator is undefined. So what we need to do then to find the value that we're going to exclude from the set of real numbers is take this denominator, set it equal to 0, and then solve. And by doing that, we're going to find the value that gives us 0 in the bottom. Okay, so if I solve this for x, and so I'm subtracting 8 from both sides and then dividing by 7, then I get x is equal to a -8/7. Now that's actually what x cannot equal, because if x equals -8/7 and I plug it in here, that will give me 0 in the denominator, and that is an undefined value. So this is the value that we will exclude from the set of real numbers. Note that the absolute values here did not play into determining the domain at all. The absolute values don't affect when the expression is equal to 0, and so we just basically ignore these absolute values in this problem. Okay. So to identify the domain then, we are taking this -8/7 and excluding it from the set of real numbers. Typically, we will write this in this class, in this section, we will be writing these in set notation, and in other classes you may end up writing domains in interval notation. But the set notation for this would be x such that x is a real number, and and x is not equal to -8/7. So set notation always starts with a squiggle bracket, ends with a squiggle bracket, and we're always identifying the variable that we're speaking about. So we're talking about x, and we're talking about x in such a way that here's what we're saying about x. Okay, so this would actually be the domain for this problem.